Yeah, this is the problem. All of you copy this. Copy example number 5. Copy this problem. Now you can just go on working on this. It is given e to the power of minus 0.9 is 0.4066. Constant value is mean is equal to 0.9. After this, you can copy the problem and then write down that is t of x is equal to 0, t of x is equal to 1, t of x is equal to 2, 3, 4, 5, 6. $91.485. T of x is equal to 1.
Sir,
Hello?
Sir.
Yeah.
N value is 250, no sir.
N value is
250.
250.
Then why I have taken as 225, sir?
1 second. Okay. Sorry. Yeah, mistake is there. You take n as 220, not 225, it is 250. Take n is equal to 250, not 225. Printing problem. Whether you are getting the answer right or wrong. Expected frequency answers there right or wrong. Kishan.
They're getting different answers, sir.
Okay, fine. Okay. Please solve the complete thing up to 7 and send the answer in the chat box. Kishan, Martia.
Yes, sir.
Hello? Okay. Do it. It is not 225, it is 250. Send the answer in chat box. Rakshita, send the answer in chat box. Hello? Expected frequencies, you will get different answers. Hello? ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes, sir.
ಓಕೆ. ಹೃತಿಕ್ ಸಾಲ್ವ್ ಮಾಡಿ ಅದು ಒಂದು ಇಮೇಜ್ ಕಳಿಸು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ. ಒಂದು ಎರರ್ ಆಗಿದೆ ಇಲ್ಲಿ, ನಾನು 250 ತಗೋಬೇಕಾಗಿತ್ತು, 225 ತಗೊಂಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಹೆಂಗೆ ಅಂತ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ, ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ. ಎಲ್ಲ ಸರಿ ಇದೆ, ಮೇಲೆ 250 ಬರ್ದಿದ್ದೀನಿ, ಬಟ್ ಇಲ್ಲಿ 225 ತಗೊಂಡ್ಬಿಟ್ಟಿದ್ದೀನಿ.
Yes, sir.
Just write 250 wherever you have 225, write 250 and solve, you'll get the answer.
Sir,
Yeah. Yes, tell me.
sir, is it 250 or 225?
I'm look at the chat box there. 225. It is not 225. It is 250. I've written it in the chat box. Check, man. Take it as 250 because your sigma f is 250. Look at the slide.
Yes.
Got
Yes.
it? Okay.
Yes, sir.
Okay. I made a mistake. I'm accepting it. I made a mistake while simplifying it.
It's okay, sir. It's okay.
Yeah. We'll start normal distribution offline on Monday, not today. Completed? Hello?
Not yet doing it.
Okay, okay, okay. Done? Ratika, Rakshita, if anybody have completed it, please put it in the chat box. Is it done? Hello,
Yes, sir.
Pratik. ಆಯ್ತೇನಪ್ಪ ಮಾಡಿದ್ದು?
Yes, sir.
ಓಕೆ, ಪ್ಲೀಸ್ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಕಳಿಸ್ಬಿಡು. ಅದನ್ನ ಒಂದು ಎರರ್ ಮಾಡಿಬಿಟ್ಟೆ, ಅದು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ, ಅದು 225 ಆಗ್ಬಿಟ್ಟಿದೆ. ಎಷ್ಟು ಸರ್ತಿ ಬರ್ತೀಯ ಹೋಗ್ತೀಯ ಕಣೆ. Hello? Completed? Okay, good. I think Hritik has done it. Are you getting it? Total 250 sigma f. Hritik,
Yes, sir.
ಈ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಟೋಟಲ್ ಮಾಡೋ 250 ಬಂದಿದೆಯಾ? ಎಲ್ಲಿ ತೋರಿಸಿದೆಯಪ್ಪ?
The next image.
ನೆಕ್ಸ್ಟ್ ಲೈನ್ ಇನ್ನೊಂದು. ಓಕೆ ಓಕೆ, ಗುಡ್. Yes, 250.014. Approximately it is 250. Good. Thank you, Hritik.
Okay.
Shall I move on to the next one? Pratika, Rakshita, Kishan, Aman.
Sir,
Yeah, tell me. ಯಾರು?
sir,
ಹೇಳಪ್ಪ.
sir, ಎಲ್ಲ ಅರ್ಥ ಆಯ್ತು ಸರ್.
ಹಾ
ಇಲ್ಲಿ ಟೇಬಲ್ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಡಿಫೆಕ್ಟ್ಸ್ ಪಕ್ಕ ಫಾರ್ಮುಲಾ ಹಾಕಿದ್ರಲ್ಲ ಸರ್,
ಹಾ,
ಅಲ್ಲಿ ಸರ್ n ಇಂಟು ಪಿ ಆಫ್ ಎಕ್ಸ್ ಅಂದ್ರೆ ಏನು ಸರ್ ಅದು?
ಪ್ರಾಬಬಿಲಿಟಿ ಪಿ ಆಫ್ ಎಕ್ಸ್ ಅನ್ನೋದು
ಹಾ,
ಪ್ರಾಬಬಿಲಿಟಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಫ್ ಪಾಯ್ಸಾನ್ ಸೀರೀಸ್ ಇದು.
ಓಕೆ ಸರ್. ಇದು
ಇಲ್ಲಿ
Okay.
ಇಲ್ಲಿ ಒಂದ್ ನಿಮಿಷ, ಎನ್ ಇಂಟು ಪಿ ಆಫ್ ಎಕ್ಸ್ ಆದ ತಕ್ಷಣ ದಟ್ ಬಿಕಮ್ಸ್ ಟಿ ಆಫ್ ಎಕ್ಸ್.
ಓಕೆ ಸರ್, ಓಕೆ ಸರ್.
ಇದು ಪ್ರಾಬಬಿಲಿಟಿ, ಇದು ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್.
ಓಕೆ ಸರ್.
n total number of trials into probability, that becomes your expected.
ಓಕೆ ಸರ್.
ಅದನ್ನ ಹೇಳಕ್ಕೆ ಈ ತರ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ. ಇದು ಒಂದು ಏನು ಅಂತಾರೆ, ಸಿಂಬಾಲಿಕ್ ನೊಟೇಷನ್ ಕಣೋ. ಟಿ ಆಫ್ ಎಕ್ಸ್ ಗೆ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತಂದ್ರು ಒಂದೇ, ಥಿಯರಾಟಿಕಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದ್ರು ಒಂದೇ, ಎರಡನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ನಾವು ಇದನ್ನ ಯೂಸ್ ಮಾಡಿದೀವಿ. ಬಟ್ ಇಲ್ಲಿ n ಅಂದ್ರೆ ಸಿಗ್ಮಾ ಎಫ್ ಅದು 250 ತಗೋಬೇಕು. ಬಟ್ ಮೇ ಬಿ ನನ್ನ ಮಿಸ್ಟೇಕ್ ಇಂದ, ಒಂದು ಓವರ್ ಸೈಟ್ ಇಂದ ಅದು 250 ಆಗ್ಬಿಟ್ಟು 25 ಆಗ್ಬಿಟ್ಟು ಪ್ರಾಬ್ಲಮ್ ಆಗಿದ್ದು. ಈಗ ಹೃತಿಕ್ ಮಾಡಿದ ನೋಡಿ, ಇಲ್ಲಿ ಹೃತಿಕ್ ಏನಿಲ್ಲ, ಪಿ ಆಫ್ ಎಕ್ಸ್ ಅನ್ನೋದು ಪಾಯ್ಸನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫಾರ್ಮುಲಾ.
ಓಕೆ ಸರ್, ಅಷ್ಟೇ.
ಅದ್ರ ಜೊತೆ ನೀನು n ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬಿಟ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. n is 250 ಸಿಗ್ಮಾ ಎಫ್.
ಓಕೆ ಸರ್, ಓಕೆ ಸರ್, ಅರ್ಥ ಆಯ್ತು. Poisson
Okay.
distribution the formula ಮೇಲ್ ಇದೆಯಲ್ಲ ಅದು e to the power of minus.
Exactly. You're right.
Okay.
You're right. You're right.
Thank you, sir.
Sir,
Yeah, tell me.
sir, in this problem, Poisson distribution tables has given 0.46.66. But if they
Ah.
didn't give, if they didn't give us, how we should find it?
They have to give. Otherwise, you cannot solve it also. They'll give.
But in the previous problem, they didn't give. You calculate 0.5432. How you calculate this one?
No, it was given, man. It was given.
Oh, okay, okay. It's up. Okay, sir. Okay.
It's above.
Got
On
it.
the above, it is mentioned.
So they will give always they will give this Poisson
They
distribution.
will give. They will give. Don't worry. They'll mention it in the bracket.
Okay, sir. Okay, good. Then good.
Okay. Either they'll give the table or they'll give the value directly.
Okay. So at the end, what we should write after final? We got 250.014.
Nothing to write. That's it. You can close it. Enough.
That's it.
That's it.
Okay.
Need not write anything. Okay, you can go on giving its conclusion and its impact, but at this point of time of your UG point, there is no need of giving any conclusion part of it. You can just stop it, because
Okay.
the conclusion you can continue it for another one page. You can continue writing conclusion for what happens 0, what happens to 1, what happens to 3 up to 7. You can go on giving 7 different conclusions, but at this point of time that is not required for your level. Abdullah, understood, man?
Yes, sir. Yes. Yes, sir. Yes.
For this problem you can write 7 different conclusions, but for you it is not included writing the conclusion part. Only calculation is there, and it's inference and drawing the meaning. Okay, drawing its final conclusion is not required for you. No, need not to mention it. You will learn it in your MBA. There they'll teach you how to draw the inferences from this. Okay.
Okay, sir.
Okay. Shall I move on to the next one?
Yes, sir.
Yeah. It's just an introduction to normal distribution. Anybody has got any doubts before moving on to this normal distribution? Anybody has got any doubts?
Sir, yes, in the exam they will give Poisson or no this binomial, so right? Binomial or Poisson, one of them.
Equal chances.
Okay, sir.
Equal chances. Any questions?
No, sir. Continue this application or normal.
Normal distribution. See, okay, this we call it as continuous probability distribution or normal distribution. It is also known as the error law or normal law or Laplacian law or Gaussian distribution. These are all the technical terms. Okay, you need not to remember all these things. And many of the applications, they depend on this normal distribution. Many of the statistical applications. Many of the statistical applications depend on normal distribution. Understood? And this is the definition, and it is no very difficult to explain for the people like non-commerce students. It is basically engineering application related one, and okay, if you skip this one, you can go on the conditions for normal distribution, when exactly the normal distribution can be applied. Okay, somebody is checking the control, I don't know. Yeah, conditions for normal distribution. It is the limiting form of binomial distribution. If you put limits to the binomial distribution, you will get normal distribution. That's what people say. Again, it is difficult to understand the concept of normal distribution by making use of this statement or sentence. And there are two major conditions. N should be very high, large. Okay, don't bother about the symbol. N is large. Normal distributions are applied for large sample size. ND is applied for large sample size. Large sample size problems. Usually, any sample size more than 30, we consider that as large. But technically speaking, okay, anything more than 120, we call that as large sample size. But generally, we consider all the samples of 384 and more are the large sample or the large samples. There are different versions of addressing what is called as a large sample and a small sample. Okay, different authors have given some different opinions, but to sum up, I can say that any sample that goes less than 30, is called as small sample. Anything more than 30, any sample size, I can say, more than 30 is called as large sample. But there is something called as law of inertia of large numbers. If you apply the concept, I'll just give you the summary. Okay, people say 120 should be the minimum required sample size to declare that as a large sample. 120 is the minimum sample which is required to declare the sample as large. But there are some statistical tables. Okay, for example, Tippett's table, and all these things you'll come to know in your higher studies. According to that, people essentially put a number. They say that 384 and more. We call it as large sample size. There is a specific formula to determine this 384 that comes under inertia of large numbers theorem and Tippett's large number generation and further things. It becomes quite difficult for me to convince. Okay, with regard to these numbers, you can just take my words. Okay, to begin with, we say that 30 or more large sample, 30 or less small sample, and conventionally we declare ourselves, say that 120 okay, is the minimum sample that is required to declare one thing as the sample as large, and going according to the statistical theorems, axioms, proof, I can say 384 is essentially the larger number, will be the essential larger number, 384 and more. Any sample size which is 384 and more, we call that as a large sample. That's about the conclusion. And neither P nor Q is very small. P and Q are high in nature. They are not the rare events. Normal distribution is not meant for ND is not meant for rare events. Rare events is only Poisson distribution. Normal distribution is not for rare events. Okay, it is used largely for almost all the kind of analysis. Normal distribution. Okay, this is the conditions to be applied. Okay, please write down this curve. Normal distribution curve. Okay, it is a bell-shaped curve. It is a bell-shaped curve. It is a bell-shaped curve. You know, a bell. Here we have the minimum and it is growth and reaches its peak and then it comes down and it just goes like that. And this is what is called a saturation point. And we are going to analyze this bell-shaped, okay, we have normal distribution is a bell-shaped two-tail curve. We call it as normal distribution is bell-shaped two-tile curve. Left tile and right tile. That is left tile and right tile. Left tile and right tile. Left tile and right tile curve. This is left side and right side. You can see. Okay, anything, the value which is less than mean, that falls in the left tile. Any value which is more than mean, that falls under the right tile. The values less than mean value will be in the left tile. More than mean values, more than mean values will be in the right tile. To understand more about right tile and left tile analysis of this normal distribution curve, I suggest you to read a statistics for management textbook written by Levin and Rubin. I suggest you to read the textbook Statistics for Managers by Levin and Rubin. McGraw edition. McGraw Publications. McGraw edition, or I can say publications. Understood? Any questions? Hello? Any questions? Say yes or no. Properties of normal distribution. This question is very important for examination for 10 marks. Explain the properties. Explain the properties of ND for 10 marks. Very, very important question. You can take it as 99.9% this question will come for examination. Are you getting my point? There are 8 or 10 points. You just copy these points and then write it. Just mention the properties. They say explain, need not explain. At least if you mention this, okay, you will be awarded some 7 or 8 marks out of 10. This will be there in section B. Properties of normal hello, yeah, tell me.
Which one is one for 10 marks? This one. Which question?
This one only. Explain properties of normal distribution. This slide, are you looking at the slide? Slide number 38.
Yes, sir, but it's okay.
Yeah, this will come for examination for 10 marks. Theory question. Hello? You're there listening to me?
Yes, sir.
Yeah, ಇದು 10 marks ಬರುತ್ತೆ 99.9%. I'm telling you. Right? Hello? Now the properties are like that. In the case of normal distribution, mean is equal to median is equal to mode. We call that as M. It is called as unimodal distribution. Okay, it is also called as symmetric series. Symmetric series. Symmetry, why? Because mean is equal to median is equal to mode. Mean is equal to median is equal to mode. Therefore, it is called as symmetric series. It is called as symmetric distribution. It is called as symmetric distribution. Okay. Now, continuing with that, you can just mention the values as it is. Yeah. And even you can explain, compare binomial, Poisson, and normal distribution. This question may appear in section C for 5 marks. You just write this table, more than enough. This may appear in section C. This question may appear in section C for 5 marks. Compare the 3 different distributions. Parameters, range, mean, and variance. Okay, that's enough. Okay, you can just mention this table. That is more than enough.
This is, sir, for 5 marks.
For 5 marks. Here, only thing is where you can say P is equal to probability of success and Q is equal to probability of failure. You need to mention. Okay, below the table, it is essential to mention P is equal to probability of success P is equal to probability of success and Q is equal to probability of failure next. Okay, this mu is called as mean. This here normal distribution is there's a symbol called as mu and SD. We read it as mu. Okay, that is mean. And here we call this as lambda. Lambda is equal to mean. Lambda is equal to mean. Now SD square is equal to variance. Mention these things below the table and you will get 5 out of 5. Mention these differences. You will get 5 out of 5. Okay. Problems I'll solve offline. And this is the theory part. Now it is almost 11 o'clock, 15 minutes. Okay, anybody, any questions? Hello?
No, sir.
Rakshita, Yashwant Raj,
No, sir.
any questions? Aman? Okay.
Sir, yes.
Yeah, tell me.
Isn't the important question, like write it in paper, what it will come from which unit and theory questions.
I am not properly getting you. What is that you are asking for? Not able to understand you, man. What is that you need? Tell me clearly. Abdullah. Hello. Abdullah. Write it in the chat box. I said properties of normal distribution will come for 10 marks. Comparison of binomial, Poisson and normal distribution will come for 5 marks. And whatever the theory that we have discussed in the case of normal distribution, maybe that bell-shaped curve, 2 tiles and all, even that you can mention it. If you want to get any more amount of knowledge about this normal distribution, the right tile and the left tile importance, I said that read the textbook. Levin and Rubin, Statistics are Managers, McGraw editions and McGraw publications, I can say, and there you will come to know more knowledge, more information about right tile and left tile of normal distribution. Okay, it's available in the library. You can just get it, or otherwise the e-version of the textbook is also available in the Google, or you can directly just go on checking it, right tile and left tile importance of normal distribution. Google it, you will come to know. Next. Yeah, this is the problem here. Now, in order to solve this problem, you need to understand some basics about the normal distribution table. And I feel that it becomes difficult for me to make you to understand about the importance or how to read the normal distribution table, and probably I can take this in a better manner, okay, during the offline classes. Is it fine? Okay, let us solve all the problems in the offline mode only from Monday. Problems on ND will be solved on Monday. Offline is best. Attend, all of you, attend my class on Monday offline. Is it fine? Any queries, any questions?
No, sir.
Okay, sir.
Yeah. If you're not able to answer this, again, this will appear for 10 marks. Normal distribution and this theory probable problems will appear for 10 marks. Normal distribution will nowhere appear in the 15-mark section. There's a rare chance, remote chance that it may come in section A, but definitely in section B, 1 or 2 questions will be there, and even in section C. Right?
Okay, sir.
Okay. Yeah. Rakshita, your EMV and EOL will be solved maybe on Monday or Tuesday. Okay, the PPT is not yet ready for that. Okay, I'll call you after this class, or you only call me after this class. Okay, I have some material. I need the PPT to be prepared for this EMV and EOL. Okay, I need 1 hour to explain that EMV and EOL. That's fine. Hello?
Okay, sir. Yes.
Rakshita is not answering. Hello? Rakshita is there or not?
No, sir.
She left. Okay.
Yes, sir.
Fine. Okay. Yes. Yashaswini, any doubt? Rajat? Prashant? Ritik? Aman?
No doubt, sir.
No doubts. See, you can take this complete unit number 5 as your optional thing to answer. Okay, complete choice you can make make use of it. Choice you can make use of it, and chapter 5 you can keep it as plan B option, because okay, things may be quite difficult compared to other sections, and we are not addressing it fully, not in complete. It's partial, it is included, and therefore okay, you may not get the complete knowledge of normal distribution at this point of time, okay, as it is the beginning one, and gradually you'll understand the ways and means of solving the problems related to ND, and that's for today. Shall I close it? If you don't have any questions,
Yes.
Yashaswini, Rajat,
No, sir.
no questions, right? If you're not able to answer the problems, better you attempt 1 or 2 theory questions from this chapter. Rest of the things you can take care of, no problem. Anyway, 15 marks, okay, you have prepared well for binomial and Poisson, and that's enough for you. 15 marks, you can attempt one theory question, properties of binomial, properties of normal, or comparison. Like that you can answer, or maybe any other question from other chapters. That's what I'm telling you. You can take this complete unit number 5 as a plan B option. Choice, I said. Understood? Hello?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah, then fine. Shall I close it? It's 11:22.
Okay,
Yes,
sir.
sir.
Thank you, sir.
Thank you. We will meet on Monday, okay, to solve problems on Harmon distribution offline. Fine. Hello?
Yes, sir. Yes, sir.
Okay,
Okay, sir.
see you. Bye.